Lakshmi, Department of Mathematics, SNS College of Technology. Today we are going to discuss about the Fourier series form sum. So I choose this find the Fourier transform of f of x equal to a square minus x square. Modulus of x is less than a, otherwise 0. So here modulus of x is greater than a is given. That means that negative value or the a plus a minus a other than this value becomes 0. That is minus infinity to minus a and a to infinity. So these values are here you won't get the function. Here alone we get the function as a square minus x square. So this is our given function, and for this function we are going to calculate Fourier transform. First we can write the Fourier transform formula. That is f of x. It is called this f of x. We can write it as f of s, which is equal to 1 divided by root of 2 pi integral minus infinity to plus infinity f of x equal to isx into dx. Here we can replace this function f of x. So 1 divided by root of 2 pi integral. Here the limit is restricted to minus a to a. So minus a to a, our f of x is a square minus x square into e power isx. We can expand this term. That is e power isx is cos sx plus I sin sx into dx. So now one here first term plus second term. Separate these two. So you will get 1 divided by root of 2 pi integral minus a to a square minus x square into the first term cos sx into dx, and then the second term is plus I into, and then write this 1 divided by root of 2 pi integral minus a to a square minus x square into sin sx into dx. So after this, the given limit is minus a to a. Here we want to check the given function is odd or even. So first this function is even function and this one is the even function. So even and even you get the even function, so you get the answer here. And the second function is this is even function and this is odd function. So even into odd you get odd function. So integration of the odd function is 0. So the second value becomes 0. You get the only answer in first term. So that is 1 by root of 2 pi integral minus a to a square minus x square into cos sx into dx. Here I said this is an even function. So even function you can write this limit as integral 2 times 0 to a. You can change the limit like this, whether if it is an even function. So we are going to calculate only these terms. Okay. Which is equal to 2 divided by root of 2 pi integral. So integrating 0 to a square minus x square cos sx into dx. So this is first function and this one is second function. In integration, product of two functions, we can proceed the Bernoulli's rule. So I am going to do that directly. Here for this term we can conclude, or else at the last step also we can conclude. So at last I am going to conclude. Up to this I am writing as it is. So for this second term I am going to use the Bernoulli's rule. So first write u value a square minus x square, and then remaining integrating cos sx in dx. These terms we are writing. So integrating cos is sin sx divided by, in integration differentiating sx you get the constant s. So this is the integration value. So first we are writing as it is, and then second term we are writing the integrated term. So after this, with the arithmetic sign put minus, and then you just think about when you are applying the Bernoulli rules. After this, first bracket differentiate, second bracket integrate. It's a basic thing. So first bracket differentiate. Differentiating this term minus 2 and then integrating sign is minus cos. So minus cos sx divided by first integration already one s is having. For the second integration another one s will come. So s in s square will come. So this is second integration when we apply for the second term, and then for the third term. So plus minus third term you get positive sign. So first bracket differentiate the term minus 2 will come, and the second bracket put minus and then integrate cos. Integrating cos is sin sx divided by, it is a third integration, already 2 we are having, so you get s power 3. So next we want to continue with this means first bracket differentiate. When you are differentiating this term you get 0. So you can stop up to this level with the limit 0 to a. Next you can apply the limit 2 divided by root of 2 pi is a common to these two terms. Okay, first I am going to apply the upper limit. So a square minus, whether we want to check first bracket or second one, any one will become 0 means no need to write. So I am applying the limit a square minus a square, I am getting the value as 0. Next model 1, 2, 3. 3 minus is there, so I am putting 1 minus here 2 instead of x a, 2a cos s a divided by s square, and then third term minus into minus plus 2 sin s a divided by s power 3. It's the upper limit value, and then minus lower limit value. So what is the lower limit? 0. So here in the first term first bracket will become 0. For the second term 0 means substitute 0, sin 0 is 0. So first value becomes 0. And here x, instead of x only we are replacing x into 0 into any value, it becomes 0. And in the third term again sin 0. So sin 0 is 0. So the third term also 0. So the lower limit all becomes 0. Okay, so only we are getting an upper limit. We can conclude this, which is equal to 2 divided by root of 2 pi in bracket. Here the denominator is s square and here s power 3. So take LCM as s power 3 and minus 2 sa cos sa plus 2 sin sa will come. After this, write in order 2 divided by root of 2 pi and take this 2 outside. Okay, and then remaining 2, yes, this is negative term and this is positive term. So write in order sin sa minus sa cos sa divided by s power 3. So this is the value of, and here 4 divided by root of 2 pi into sin sa minus sa cos sa the whole thing divided by s power 3, which is the value of f of s. So this is the value of this function Fourier. We calculated the Fourier transform for this function a squared minus x squared as this. So thank you.